So this is a video of the progress check review. We did a number of these slides in class. We did about 5 slides in class. I'm going to go over every slide. So here on slide 1, you want to plug in these numbers. So if I plug a -3 in here for x, -3 plus 2 is -1 cubed is -1 minus 2 is a -3. And then if I plug a -2 plus 2 is 0. Cubed is 0, minus 2 is -2. And then if I plug a -1 in, -1 plus 2 is 1, 1 cubed minus 2 is -1. And then plug a 0, 0 plus 2 is 2, cubed is 8, minus 2, 8 minus 2 is 6. And I plug a 1 in, 1 plus 2 is 3, 3 cubed is 27, minus 2 is 25. And plug a 2 in, 2 plus 2 is 4. 4 cubed is 64, minus 2 is 62. All right, and if I want to make the inverse function, I'm going to say g of x because I noticed in class the f inverse of x notation doesn't work. So the last thing I did here was subtract 2. So the first thing you're going to add 2 and then take the cube root. So the nth root, so the cube root of x plus 2. And then this plus 2, the opposite or inverse is minus 2. And then the inverse graph, you just want to take this original table and switch the x and y. So -3, 3 is still -3, 3. -2, 2 is still -2, -2. And -1, -1 still remains the same when I swap the x and y. And then 6, 0. Oops. 6, 0. So notice the points show up on the graph. And 25, 1. And that's not going to show up on this graphic because I'd have to make the scale different. All right, so it's probably good enough. Here's a quick way. I think I showed you this in class. A quick way to get the table is go to this gear symbol, and then next to the function, just convert to table. And so notice that -2, 2 is same as I put here, -1, 1. So if you have access to Desmos on the progress check, a quick way is just go to this gear symbol and get the table that way. So here, for this one, you can do the same thing. So scroll down, get the table, and so -2, 2, -1, 1. If I plug a 6 in for x, whoop, let me do that again. 6 should be 6, 0 anyway. 6, 0, 25. Get a 1. 62 should get a 2. 621, so 62 should get a 2. All right, so easy way to get the table, go here, and then next to whatever function I have, just convert it to a table. So slide 2, if I plug a -3 in for x, -3 plus 1 is -2 squared is 4, minus 3 is 1. So the dot shows up there. And then negative 2 plus 1 is negative 1 squared is 1. So I get minus 2. And negative 1, 0 minus 3 is negative 3. And 1 minus 3 is negative 2. And then 2 squared 4 minus 3 is 1. 2 plus 1, 3 squared is 9. Minus 3 is 6. And 3 plus 1 is 4. Squared is 16. Minus 3 is 13. The inverse function. So the last thing I did was subtract 3. So I'm going to add 3 to x and then take the square root. So 3 of x equal square root of x plus 3 and then minus 1. And then 1, negative 3, this switching the x and the y, negative 2, negative 2. Something's wrong with this point here. So if I plug in negative 3 in here, 4 minus 3 is 1. Oh, I know what's wrong there. Let's see. Would be when x is greater than, so the restriction would be x is greater than negative 2. Let's see what's going on here. So if I plug in 1 in here, it's 4. Square root of 4 is 2. 1, 1 is on the graph. 1, negative 3 would be the bottom half of this. I didn't graph the bottom half, so. And then negative 2, 0. That's on there. So I just want the points that are on the top half of the inverse parabola there. And 1, 1 I already got. 6, 2. Alright, that's probably enough. And like I said before, a quick way to get the table is just hit the gear symbol and then click on table. So this table should match this one here. And then click on the gear symbol down here. If I click on the table, should match this one here. So negative 2, in other words, should be 0, 6, 2. This point is actually not on the inverse, so. So if I plug in a 6, I get a 2. 13, you should get 3. All right. So solve the following equation and check for extraneous solution. If the solution extraneous, right, no real solution. So this first one, to subtract 6 from both sides, you get negative 3 equals square root of x plus 2. And then the next step would be square both sides. And then last step is subtract 2. So if I plug that back in, and right here, I could stop because the square root of something equal negative 3. That's not going to ever work. But 7 plus 2 is 9. Square root is 3. 3 plus 6 is 9, not 3. So this is no real solution. And then this one, add 3 first. And then square both sides. And add 2. If I plug that back in, 66 minus 2 is 64. Square root is 8. Minus 3 is 5. So that works. Next one, subtract 4 from both sides. Negative 2 equal cube root of x plus 1. That's the first step. Second step, cube both sides, so negative 8 equal x plus 1. And subtract 1 equal negative 9. So negative 9 plus 1 is negative 8. Cube root, negative 2 plus 4 is 2, so that works. And then the last one here, add 1 to both sides, so you get 3 equal cube root, so nth root, cube root of x minus 3, and then cube both sides, so 27 equal x minus 3, x equal 30. Minus 3 is 27, cube root is 3, minus 1 is 2, so it works. Consider the function when x is 1 and when x is 9, and then find the rate of change. So when x equal 1, y is equal to 2. X equal 9, y equals 6. So you have these 2 points, 1, 2, and 9, 6. So the rate of change then is 6 minus 2 over 9 minus 1. So you get 4/8 equals 1/2. Next, plug in the 8. So when x is 8, cube root 8 is 2, y is 6. And when x is 27, Plug that in. Cube root of 27 is 3 times 3 is 9. So y 9. So you're looking at these 2 points. 8, 6. And 27, 9. So you do 9 minus 6 in the numerator and 27 minus 8 in the denominator. Be over 19. Which expressions are equivalent? So if I look at this one and say the fourth be the fourth, this one's also going to be a to the fourth be the fourth. And same with that one. So all these are equal to a to the fourth b to the fourth. And this one is already simplified. Can't do anything with that. Can't subtract that there. So in slide 7, very similar, but it's one which is not equivalent. So this one is xy cubed. So is this one. Same thing with this one. X squared y cubed. All these are x squared y2. This is not. So the only one that's not the same is this one. All right, so what's the domain and range of the function? So probably the easiest thing to do there is get the Desmos calculator again. So I'm going to open a new tab here and square root of x minus 3 plus 1. And you can write this as f of x. You can see you don't have to here. All right, so the domain starts from 3 to infinity. The range is right here, 1 to infinity. So the domain and range, to look at the endpoint, that's going to affect the interval notation for domain and range. So the domain for this one, 3 comma infinity, and the range is 1 to infinity. And then the domain and range for this one. So once again, back to the calculator. I'll take this one off. Equal negative square root x plus 3 minus 2 . All right, the domain would be negative 3 to infinity. So this is negative 3 to infinity. So notice I'm using my graphing calculator to help me here. And the range then is negative infinity to negative 2. So negative infinity negative 2. bracket. And then writing these in radical form on slide 10. So, nth roots. The root is in denominator, so 5. And then a to the third. This one, the root is 7. And the exponent of x is 5. And this one is the 5th root of x cubed. And the last one is a cube root of 8 squared. So denominator is the root by the radical symbol. The numerator is the exponent of the variable. Which the following statements are true about all exponential graphs. So this is not always true. They can be increasing or decreasing. So I'm going to check that one. The range depends on where the asymptote is. So it's not going to be all real numbers. The domain's all real numbers. That's always true. Has a vertical asymptote? Nope. They have horizontal asymptotes. It always has a y-intercept. Often has an x-intercept, depending on if you move the graph up or down, but it doesn't always have an x-intercept. All right, so here you're just plugging in the compound interest formula. So A equals 50 1 plus the rate is 0.05 in decimal form divided by the number of times you get interest. If it's quarterly, you get it 4 times a year. And the exponent here. 4 times 3, which would be 12. And you get approximately $290.19, which would be a little bit short for PS5, but maybe he could get some help from his parents after he showed that he was willing to keep his money in a savings account. All right, and to write these in exponential form, I'm going to give you some practice on slide 12, especially, and 13 and 14. All right, so for slide 12, we didn't get the logarithms yet, but it's just writing, this is the base, and this is the exponent, and this is the number. So this one will be 2 exponent 4 equals, so 2 is the base, exponent 4 equals x. This one will be 3 squared equal x. So 3 squared equal x. And then 4 exponent x equal 2. And this last one, x squared equal 4. So base exponent number, we usually say base exponent number, base exponent number, base exponent number. If I solve these, this would be 16, 9, 4 to the 1/2 power, or the square root of 4 is 2. And this one would be a 2. 2 squared is 4. All right, the number of bacteria in the petri dish doubles every 20 minutes if the dish initially has 200. So you want to write this kind of equation. And we talked about this already. B exponent t. We just want to plug in now. E of t. The initial value is a, so it's 200. The multiplier is double, so the multiplier is 2. And then exponent is 20t. So after 20 minutes, this would be one 20-minute period, and then two 20 minutes periods, and so on. All right, I'm going to stop sharing there.